Good afternoon and welcome to Cheg's live Stoichiometry Office Hours. There are office hours all week that I encourage you to join. Tonight we'll be focusing on chemistry and the math involved in chemistry. My name's Allison. I'm going to be hosting the live stream tonight. I'm a student at the University of Louisville for chemical engineering. I have TA'd for chemistry before. I have been a student learning assistant for nursing chemistry and regular chemistry, and then I've been a tutor for organic chemistry, regular chemistry, and calculus. So I love teaching, love math and science. I hope that you guys get something good out of this live stream tonight. I encourage you throughout this live stream, ask any questions that you have. If this is your first time, type any question you have in the chat of wherever you're streaming from, whether that be YouTube or Twitch. And if you are coming back, you know the drill. To start us off, I have some questions. I'm going to encourage you throughout these questions to be involved and participate. I might ask you a step for the question or how you would solve the problem as a whole. And then I want you to try to beat me to coming to the answer so that we all are learning something, or we're checking our learning and we're practicing so that we can do good on those assignments that we have for our classes. Thank you so much to Chegg for putting this together, and let's get started. Thank you again for joining. So tonight we're going to start off with a little warm-up talking about protons, neutrons, and electrons in different elements. So if you have a periodic table on hand, I'll give y'all a few seconds to get it out. I also recommend, if you don't have one on hand, just on your phone, pull up a periodic table or something. It's good to get comfortable using it. We are going to find, to start out, how many protons, neutrons, and electrons zirconium has. So Zr is zirconium. Let's see if I can spell this right. So Zr is zirconium, and we are going to find that on the periodic table. So I am looking, this one's a little bit tougher. Okay, it's number 40 on the periodic table. So its atomic number is 40. This is important for what we are going to be doing, which is figuring out the protons, neutrons, and electrons. And then we also want to find out its atomic weight. So that will be the number with the decimal points on the periodic table. So the number with the decimal points, which is the atomic weight, is 91.224 AMU. AMU just stands for atomic mass units. So to find protons, neutrons, and electrons, you're going to need to know your atomic number and your atomic weight. This is going to be important. Pay close attention because the next problem is basically the same as this one with just a different element. And I'm going to have you guys try that one on your own. So to start out, we are going to find the number of protons. Real quick, before we get into solving, does anyone have any idea the number of protons in zirconium? Does anyone know how to find the number of protons? If you've taken chemistry classes before, you might remember, but I feel like this is a really easy thing to forget, so it's always nice to refresh and remember what the periodic table is used for. So how many protons is in zirconium? I'll give y'all about 10 more seconds. All right, 3, 2, 1. Zirconium has 40 protons. If you're wondering where did you get 40 from, protons equals the atomic number. Protons always equals the atomic number. So protons always equals atomic number. The atomic number is 40, so we have 40 protons. Hopefully that's easy enough. If you have any questions, again, feel free to type those in the chat from wherever you're streaming from, and I'd be more than happy to answer them for you. I'm here as a resource for you. So get anything you can out of me. All right, now we want the number of electrons. I think electrons is the easiest. So we want how many electrons there are. So I'm going to give y'all 10 more seconds again, if maybe you've seen this before. How many electrons are in zirconium? All right, 3, 2, 1. Since Zirconium is just Zr. It's not an atom with any charge. It's not a cation, not an anion, which means it doesn't have a plus or minus in that top right corner. Electrons equals protons. So we'll just write a little note. No charge means electrons equals protons. And that you can kind of think makes sense because electrons are minus signs, protons are plus. If they equal each other out, there's no charge. Whoops, almost dropped my pen there. So there's going to be 40 electrons. So in this case, if the element is neutral, electrons will also equal the atomic number. All right, now we want to move on to neutrons. Neutrons are a little bit more confusing than protons and electrons for neutral elements, but I think we can get it. So I'm going to give y'all 10 seconds how many neutrons are in zirconium. If the atomic weight is 91.224 and the atomic number is 40, both of those numbers are important information for finding the number of neutrons. Got 10 seconds. How many neutrons are in zirconium? All right, 3, 2, 1. So to find neutrons, we do atomic weight minus atomic number. That's always going to be our formula. So get that engraved in your brain if it's not already. Neutrons equals atomic weight minus atomic number. So we're going to do 91. We kind of just round to whatever decimal whole number is closest. So whatever is the closest whole number that you would round to, that's what you round to. So since it's 0.2, I'm rounding down to 91 minus 40. So I would get 51 neutrons. Hopefully that makes sense. I know we haven't really done this before, but if you've seen chemistry before, it's pretty simple, nice thing to catch on and a quick skill to learn. So now I told y'all to pay close attention because you would be solving the next problem. You have 1 minute to tell me how many protons, neutrons, and electrons silver has. Your 1 minute starts now. If you're just joining, it is so great to have you on. This is Cheg's Live Stoichiometry Office Hours. I'm your resource tonight. Ask me any questions you can by typing them in the chat. I'd be more than happy to answer them for you live right here, right now. So any questions you have, just type those. And we are currently trying to figure out how many protons, neutrons, and electrons silver has. I'm going to give you all about 45 more seconds to figure out that information. And if you're confused on one part, like if you only know how many protons it has, you can tell me that too. You don't have to tell me all three. Any information you have about this problem, let me know. That way we're all checking our learning and we're all making sure that this live stream is beneficial and that we're learning something. That way we can do great on our assignments. All right, about 15 more seconds, guys. All right, 5, 4, 3, 2, 1. So the atomic number of Ag, which Ag is silver, the atomic number is 47. And then the other piece of information we need is the atomic weight of silver. So our atomic weight is 107.86 AMUs. So we have the atomic number, the atomic weight. For protons, we said at the problem before, we said that protons for a neutral atom, or in general, protons is always equal to the atomic number. So there's 47 protons. For electrons, we also said if it's a neutral molecule, protons equals electrons because those charges need to cancel out. So we're going to say 47 again. And then protons, remember up here, we have what our formula is. So atomic weight minus atomic number. So you would do 108. This time we're rounding up because that 0.8 indicates to round up. So 108 minus 47 we put that in the calculator and we would get 61. So in molecular silver with no charge, there's 47 protons, 47 electrons, and 61 protons. I don't know why I wrote protons at the bottom. Oops. There's 61 neutrons. Sorry about that. Sorry if I confused you guys. But there are 61 neutrons. So we went protons, electrons, neutrons. Again, any questions you have about this, let me know. I'd be happy to go over it in more detail. We're going to do one more challenge problem for this to warm up. So now I want you to tell me how many protons, neutrons, and electrons Ca2 plus has. So how many protons, neutrons, and electrons? This is a challenge problem. So remember I talked about how some of these were neutral molecules. That's how we determine them. How would you determine protons, neutrons, and electrons if it was not a neutral molecule? I'm going to give y'all 1 minute. If you're just now joining this live stream, it is so great to have you. I'm Allison, your host. I encourage you, ask any questions that you have. I would be more than happy to be a resource for you and answer those, give you some new knowledge about chemistry, and make this live stream worth your while. So thank you so much for joining. Also, if y'all see that QR code in the top left, that is our schedule for all office hours throughout the week. I encourage you to join any of those you have classes with. There's some great instructors and hosts that will teach you a lot about the subject. So I encourage you to take a look at those. Got about 30 more seconds to solve this problem of how many protons, neutrons, and electrons there are in calcium 2 plus. So that Ca is calcium. We're learning all about the elements on the periodic table today. You've got about 15 more seconds. All right, 3, 2, 1. Okay, so our atomic number of calcium equals 20. Our atomic weight of calcium is that number with the decimal points. Atomic weight is 40.078 AMUs. So we have our atomic number, atomic weight. For protons, if you said 20 protons, absolutely correct. Protons always equals atomic number. So if you said 20, give yourself a pat on the back. For electrons, now this is where it gets a little weird. So we have that our charge on the calcium is 2 plus. We have 20 protons. So we kind of want to think of it as an addition-subtraction problem. What value of electrons would we need to get a plus 2 charge? So if we have 20 pluses here, because protons are a positive charge, how many electrons would we need to get that whole element to have a 2 plus charge, so a positive charge? We would need 18 electrons, so 18 minuses. If that is kind of confusing to you, you can set it up as an equation. You can go 20 minus x equals 2. So this is how you would think about it mathematically. So 20 minus some number of protons equals a positive 2 because of that positive charge right here. So we just solve for x. We'd have 20 equals 2 plus x, and then 18 equals x, and that's how we get electrons. Hopefully that makes sense. If it's still a little confusing, it's kind of difficult to comprehend the first time that you see this. So let me know and we can do more practice if that's something that we want to work on. And then last, we're going to find our neutrons the exact same way. So just that atomic weight minus that atomic number. We would round the atomic weight down to 40 because that 0.07. So it would be 40 minus 20 equals 20 neutrons. So 20 protons, 18 electrons, 20 neutrons. Hopefully that's making sense. If it's making sense, you can send a thumbs up in the chat section of wherever you're streaming from, just so that I know everyone's on the same page. And now let's move on to some more talk about elements. but now specifically electrons. So we're going to do an electron configuration of calcium. So we've done a few electron configurations in past weeks, but if this is your first time joining this live stream, no worries. I would be more than happy to go in detail of this with you. So if you have any questions at any point, just type that in the chat of wherever you're streaming from. So we want the short, long, and spin configurations of calcium. So we determined that calcium has calcium has 20 electrons, because for this part, we're not concerned with the 2 plus. So naturally, if calcium was a neutral molecule, it would have 20 electrons. Hopefully that makes sense. If you're like, where'd you get the 20 from? We just said it was 18. I can go over it with some more visual detail, but since it's neutral, we're using 20. So we want the short, long, and spin configurations of calcium. So let's start with the short. It's always the easiest. Pull out your periodic table again. You're going to need it. We're not putting the periodic tables down for a while today. So we need the periodic table. We find calcium on the periodic table. It's on the 4th row down in the 2nd column. So it's right by the K, which stands for potassium. So we want to find short configuration, which means we use the noble gas before calcium as a placeholder, and then we write the electron configuration after the noble gas. So to find the noble gases are found in the very right row of the periodic table, or the very right column. So to find the last noble gas, we're going to go up 1 row and all the way to the right of that row. So in this case, our last noble gas is argon. So we're going to put argon in brackets. This is like how you I don't know who made this up, but this is how you do short electron configurations. This was the style they wanted. This is the style your teacher's going to require. So even though it might be confusing and like, why did they choose this? It's still a really good thing to know. So we went up 1 row all the way to the right, and we're at argon. And then we just need to write the electron configuration for after argon. So I'm going to give y'all 15 seconds. What is that electron configuration after argon to get to calcium? We've had some practice on this, so I feel confident on having you all answer. I know that we've learned so much about chemistry, and we're going to continue to learn, continue to practice. So you've got about 5 more seconds. What is that electron configuration after argon for calcium? All right, 3, 2, 1. It's all it is 4s2. If you said 4s2, give yourself a pat on the back. We just represent 4s2. That represents potassium and calcium. So that's our short. Now we need our long electron configuration, which for long electron configurations, that means we can't use the shortcut of argon. We just need to use the whole and do the whole electron configuration. It's a bit time consuming, but again, super important skill to know. So I'm going to walk you all through it. We are going to start at hydrogen in the top left. Hydrogen and helium represent our 1s orbital. There's 2 electrons in that 1s orbital represented by 2 elements. We then go down a row. We should be at Li and Be, which stands for lithium and beryllium. That is our 2s orbital. There's 2 electrons, 2 elements. Then we go right across that big space in the periodic table, and we should be at B, which stands for boron. Boron, carbon, nitrogen, oxygen, fluorine, and neon are all going to be our 2p orbital. There's 6 elements in that orbital, 6 electrons. We go down and back all the way to the left. We're at Na. Na is sodium. Sodium and magnesium are represented by 3s2. We go all the way to the right. We're at Al, which is aluminum. Aluminum, silicon, phosphorus, sulfur, chlorine, and argon are all part of that 3p orbital. There's 6 elements, 6 electrons in that orbital. We go down all the way to the left, and now we're at this 4s2, so we can just write that. So the 4s2 stays the same, and then, fun fact, all of this right here is what argon's electron configuration is. So that placeholder just stands for all of that. And then we have one more part left of this question, and it is, what is the spin configuration of Ca? So what's the spin configuration of calcium? I'm going to give y'all 20 seconds. Tell me everything you know about spin configurations. Tell me the rules, what works, what doesn't, how many up spins there are going to be, how many down spins. Anything you know, you have 20 seconds starting now. All right, about 10 more seconds. Tell me anything you know about spin configurations. 3, 2, 1. So there's a few rules of spin configurations. If you got them correct, great job. Pat yourself on the back. We have to have an up and down spin in every orbital. We can't have both 2 up spins, 2 down spins. Up and down spin in every orbital. Then we have to do all up spins in a subshell before we can do down spins, or all down spins before up spins. We can't mix them before all the electrons are filled. I know those are like really weird rules. They have weird names. They're the off-ball principle and the Pauli exclusion principle. I had to learn them, but I don't think a lot of chemistry teachers require you like knowing what rule stands for what. I think they just want you to know how to do these spin configurations. So let's write it out nice and easy. We have the 1s orbital with 2 electrons represented by that 2. So we have 1 up, 1 down arrow. Same with the 2s. Got that 2, 1 up, 1 down orbital. 2p. That's going to have 3 subshells. So 3 lines. We're at 2p. Up, 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 down, down, down. 6 arrows, 6 electrons. 3s. Up, down, 2 arrows, 2 electrons. 3p6, up, 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 down, 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 6 electrons, 6 arrows, and then last but not least, 4s, up, down, 2 electrons, 2 arrows. So that is our spin configuration of calcium. Hopefully that's making sense. If you have any questions on electron configurations, again, feel free to type those in the chat. I'd be more than happy to go over them with you. And if you're just now joining, thank you so much for joining this live stream. It is so great to have you. We're going over stoichiometry, chemistry, math, how chemistry and math go together. So any questions you have about chemistry, math, stoichiometry, how they fit together, type those in the chat. I'd be more than happy to answer them for you. I want to be as good of a resource as I can. So any knowledge you can get out of me, I encourage you to tonight. Now let's find the limiting reactant if I start with 20 kilograms of each reactant. So we have C4H10, which I believe is benzene, and then we have O2, carbon dioxide, and H2O. We want to find the limiting reactant. Limiting reactant is basically which of these reactants, so benzene and oxygen, which of these causes me to create less product. So what's going to limit me from making more product? It's always one or the other. And so the first step in solving this is to balance the equation. I'm going to give y'all a 30-second head start to balancing the equation. Try to beat me to solving it. In 30 seconds, I'm going to start, and we will see how we're doing. So you have 30 seconds to balance this equation. All right, about 15 more seconds, and then I'm going to start. Three, two, one. Okay, so if you're still balancing, keep balancing. If not, if you are stuck, watch me and I'll show you what I'm doing. So I'm just checking. I have 4 carbons over here. I'm going to put a 4 as my coefficient on the right so that I have 4 carbons on the left, 4 on the right. Then I'm going to my H's. I have 10 H's. I'm going to put a coefficient of 5 there because I want 10 H's on the left, 10 H's on the right. I'm then going to look at my oxygens. I have 8 plus 5, 13 oxygens on the left. So I'm going to have 6.5 oxygens on the right. Now, you can keep it like this. Some teachers will let you. Some teachers are going to require you to make those whole numbers. So my next step is just to multiply everything by 2. So I'm going to have 2C4H10 plus 6 plus 13O2. Forgot I had to multiply everything by 2 plus 13O2 yields 8CO2 plus 10 H2O. That's my balanced equation. We'll do one final check. 8 C's, 8 C's, 20 H's, 20 H's, 26 O's. We have 16 plus 10 O's, which is 26. So my equation is correctly balanced. So now what I want to do is find the limiting reactant. I'm going to give y'all, let's do 30 seconds. Tell me how you would solve for the limiting reactant. 30 seconds starting now. About 20 more seconds. Ten more seconds. Anything you know about this problem, let me know. All right, guys. 3, 2, 1. So to find the limiting reactant, we're going to start with what we're given. Every stoichiometry problem, we start with what we're given. We start with 20 kilograms of each reactant. So 20 kilograms of C4H10, 20 kilograms of oxygen. We are eventually going to want to get all of these kilograms to moles of a product. I'm going to choose CO2. I always choose what's first. You can choose either reactant to take both of these kilograms to. So to get from kilograms of C4H10 to moles of H2O, we're going to need a few little steps. First, we need to get to grams of C4H10 and then moles of C4H10 and then moles of CO2. Same with the bottom. I know that's a lot of steps, so we're going to go ahead and write it out so it's easier to visualize. If at all during this process you have any questions about limiting reactants, I know we've had some limiting reactant questions. Feel free to type that in the chat. I'd be happy to go over it in more detail, do some more practice problems. But we are going to go from kilograms of C4H10 to grams of C4H10. And then let's just go ahead and map out what we're going to do for both of them. So grams to moles. Then we're going to go moles to moles of CO2. So that's our map. That's what we're going to do for the top. Same on the bottom. We're just going from O2 to CO2. So kilograms of O2 on the bottom, grams of O2 on the top. Grams of O2 on the bottom, moles of O2 on the top, moles of O2, moles of CO2. I went through that a little bit quick. So any questions on why I did those steps specifically, let me know. But now we need a conversion from grams to kilograms. I know y'all know this conversion. 20 seconds. Tell me what is the conversion from grams to kilograms. Let's see how well our memorization is going. 10 seconds, guys. All right, 3, 2, 1. 1 kilogram, 1,000 grams. I knew y'all knew it. Y'all are so smart. You should be so proud of yourselves. 1 kilogram has 1,000 grams. Now we want to go from grams to moles. What do we need for grams to moles? We need molar mass, our favorite thing ever. I told you we're not getting rid of that periodic table tonight. So pull back out that periodic table. We need to find the molar mass of C4H10 and O2. Luckily, these are pretty easy ones. O2, super simple. We have 2 moles of oxygen times 16 grams per mole. We have 32 grams. So that is our molar mass of oxygen. So we know there's 32 grams per 1 mole. At the top, we have 4 times 12.01. So 4 moles times 12.01 grams per mole for carbon. So 48.04 grams. And then 1.01 times 10. So 10 moles, 1.01 grams per mole. This is for hydrogen, 10.10 grams. I'm moving through this super quick, but we've done a lot of practice with it. But if you have any questions, let me know. We'll work through molar mass slower. Then we want to add this up all in our calculator. So I'm going to get 10.10 plus 32 is 42.1 plus 48.04 is going to be 90.14. That is our... Actually, that was really silly of me. We're not adding all the molar masses together. We just needed to add C4H10s, so the 48.04 and 10 plus 10. Don't add the 32. That would be wrong because the 32 is just for the oxygen. Silly mistakes when I try to talk and work at the same time. So we're going to add 48.04 plus 10.10. So you have 58.14 grams per mole of C4H10. Hopefully, again, that makes sense. If not, there is no worries. We can go over it in more detail, so just let me know. So again, 58.14 grams in 1 mole. Now, we want to go from our moles of C4H10 to moles of CO2 and moles of O2 to moles of CO2. So we're going to put, for moles of C4H10, we have 2. I got that 2 from right here. Hopefully y'all can see that. I'm highlighting it right now. That's where I got the 2. For CO2, I'm going to put 8. Just highlighted where I got that from. So look for the yellow on the screen to see where I'm getting those numbers from. We're going to do the same for O2, that coefficient of 13 and 8. Now y'all get the fun part. 1 minute, start putting these in your calculator, letting me know what you get. If you haven't known anything tonight, I have full faith that y'all can put this in the calculator. I believe in y'all. You've got 1 minute. Put it in the calculator starting now. We've got about 30 more seconds. So again, just start putting those values in your calculator. All right, 3, 2, 1. So if you were a little lost just on maybe how I had this set up, in my calculator, I'm putting for the top problem, 20 times 1,000 divided by 58.14 times 8 divided by 2. You should have got, wow, this is a lot of moles. This is what I get for putting kilograms. You should have got 1375.99 moles of CO2. Now let's do the bottom. So I'm going to put 20 times 1,000 divided by 32 times 8 divided by 13. And I'm going to get 384.6 moles of CO2. So what is the limiting reactant is now the question I'm going to ask you. We figured out how much each of these reactants creates of moles of CO2, which is our product, which is the limiting reactant, remembering that limiting reactants create less product. So if you said our limiting reactant was oxygen, you're absolutely correct. That's because oxygen creates only 384.6 moles of CO2, while C4H10 creates 1,375.99. So that is our limiting reactant is O2. We'll write that just so we remember. Limiting reactant equals O2. So now we have like a second part to this problem. If you're just now joining, it's so great to have you. My name is Allison. I'm your host for Cheg's Stoichiometry Live Office Hours. Any questions you have, type those in the chat. My goal is to make chemistry easier for you. Use me as a resource. Get all the knowledge you can out of me. So we are wanting to know what's the excess reactant and how many moles of water can be created. Any questions you have about this problem, homework, things you went over in class, type those in the chat, and I would love to help. So I'm going to give y'all, let's do 30 seconds. What's the excess reactant and how many moles of water will be created? All right, 20 more seconds, guys. I know we know this. We are so smart. We can do this. What's the excess reactant and how many moles of water can be created? All right, so excess reactant is pretty simple. It's whatever is not the limiting reactant. So our excess reactant in this case is C4H10. It creates, like the name says, it creates excess CO2. So it's creating that 1375 moles compared to that 384. So our excess reactant, C4H10. So now what we want is how many moles of H2O can be created. The way that we're going to solve this is we're going to start with how much limiting reactant we have. So we have 20 kilograms of O2, and we want to get from 20 kilograms of O2 to moles of water. So same process we did up here, just with water. When we want to figure out how much product can be created, we never start with a limiting reactant. We never start with the excess reactant. Sorry, my bad. We always start with the limiting reactant because think excess reactant isn't reality because that limiting reactant is limiting how much product can be made. So we do kilograms of O2 to grams of O2, grams of O2 to moles of O2, moles of O2 to moles of H2O. If you're wondering where I got those values, that's what we mapped up here. So I'm just copying that same sort of format. 1 kilogram is 1,000 grams. 1 mole has 32 grams of oxygen. 1 mole of O2, this should be H2O, my bad, guys. 1 mole, what am I doing? Oh my goodness. Okay, so back to that balanced chemical equation, we look at those coefficients. So we have 13 as the coefficient for our oxygen and 10 as the coefficient for our water. So now we're going to put that in our calculator. We're going to put 20 times 1,000 times 10 over 13 times 32, and that's going to give us our moles of H2O. So you've got 30 seconds. Put that in your calculator. 20 times 1,000 times 10 divided by 13 divided by 32. So you should have got that we can create 480.77 moles of H2O. If you didn't get that, or if you have any questions, let me know. I'd be happy to go over it in more detail. I think that's all the limiting reactant practice we have for tonight. But again, I'm really just want to help you and cater to what you need. So if you need more limiting reactant practice, if you're needing something that I'm not going over, type that question in the chat and I'd be more than happy to answer it for you. Now we're going to move on to some more true stoichiometry. This is how many molecules is in 30 hectograms of lithium. I don't think I've talked about hectograms on the live stream yet, but if you know your metric units pretty well, hectograms should not be anything new to you. I'm going to give y'all, let's do a minute to figure out the answer to this problem. In a minute, I'll start writing. So I think with enough practice, this problem is very doable in a minute. So if you've been on a lot of live streams, you'll probably know how to do this. But again, in a minute, I will start working on this and we'll all check our answers together. Once you have that answer, type it in the chat so that we can all check. All right, about 40 more seconds, guys. "25 seconds. Again, try to solve this problem. Try to check your work. See how you're doing with stoichiometry knowledge. All right. 5, 4, 3, 2, 1. So we want to go from hectograms of lithium 2 molecules of lithium. There are quite a few steps in this. So if we didn't get it done in the 1 minute, very understandable. We're going to start with what we're given, number 1 rule of stoichiometry. So we start with 30 hectograms of lithium. We want to go from hectograms of lithium to grams of lithium. That's because we always need to go to a base unit. Grams is our base unit. Hecto is just that prefix. So grams is our base unit. Then we're going to go from grams of lithium to moles of lithium. And then we would go from there, moles of lithium to molecules of lithium. This is going to end up being a really big number, but it's going to be fine. Now, if you know those metric units, 1 hectogram has 100 grams. Yeah, I just got a comment from Yash Vaish on YouTube. We are right now solving how many molecules is in 30 hectograms of lithium. So we're just setting up the problem and we are plugging those numbers in. If you have any questions about the setup or any questions about the problem as we solve it, let me know and I'd be more than happy to explain it to you. But we have 1 hectogram is 100 grams. And I just got that number from those prefix values. Hecto is 100. Centi is like 1/100. So 1 hectogram, 100 grams. Now I want to go from moles of lithium to grams of lithium. What I need for that is I need the molar mass of lithium. So I'm pulling back at that periodic table. I told y'all you weren't going to get a break from it today. The molar mass of lithium, that number with the decimal, is 6.94. So there's 6.94 grams of lithium in 1 mole of lithium. And then last but not least, I need that value from moles of lithium to molecules of lithium. 1 mole, 6.02 times 10 to the 23rd molecules of lithium. Now it's time to put that all in my calculator. So I'm going to put 30 times 100 times 6.02 times 10 to the 23rd. And then I'm going to divide it by 6.94. Yash on YouTube, I'm not familiar with the terminology, G, but I could know what it is. I might just call it something different. So if you have any examples of G questions, type those in the chat and I would be more than happy to help and answer those questions. So now I'm going to put this in my calculator. You guys can put it in your calculator too. So 10 to the 23rd times 6.02 times 100 times 30, and then dividing by 6.94. All right, that's a lot of decimals. Let's see, we have 3, 6, 9, 12, 15, 18, 21, 24, 26. So our answer is 2.6 times 10 to the 26 molecules. That's a lot of molecules, but molecules are super, super small. So if you have 30 hectograms of lithium, you can think there would be a whole lot of molecules. So 2.6 times 10 to the 26 molecules is the correct answer. If you have any questions on how I got there, let me know in the chat. I would love to help. And any questions you all have, type those in the chat and I would love to be a resource to you. If you're just now joining, so great to have y'all. We have about 16, 17 minutes left of this live stream. So now's your chance. Get those questions in. Until we have a few, we're going to move on to converting 700 miles per year to inches per second. I don't know why someone would be traveling 700 miles a year, but I love like the double conversions. I think they're super fun and great stoichiometry practice. So we are going to do the problems for a double conversion. Let's see. G is an entrance exam for engineering. I am a chemical engineering student, so any chemistry engineering questions I can definitely help with. So type those chemistry engineering questions in the chat and I would love to help. So now we want to go from miles a year to inches per second. We first want to focus on one thing to convert. I'm going to start with converting miles. I always start with the top. I think it's so much easier. So I'm going to put miles on the bottom. One conversion I know off the top of my head is miles to feet. So we're going to do feet to miles, and then I know feet to inches. Then I'm going to look at the bottom, and I want to go years to seconds. So I know the conversion of years to days, and I know days to hours, and I know hours to minutes, and I know minutes to seconds. So we're going to have a lot of conversions, but it's going to be great practice. So if you're wondering why I alternated top and bottom, that's so the units cancel out. I'll show y'all while we're doing it how the units cancel out. So 700 miles to miles. We have 1 mile is 5,280 feet. So that is our conversion, 1 mile, 5,280 feet. That's just something that I have in my brain. And then we can do feet to inches. That's one almost everyone knows, at least if you grew up in the United States. So 1 foot is 12 inches. And again, feet and feet cancel out. Then we want to do years. Our years and years are going to cancel out. 1 year is 365 days. And then we have days to hours. 1 day, 24 hours. Hours to minutes, 1 hour, 60 minutes, minutes to seconds, 1 minute, 60 seconds. We're going to put all of that in the calculator. So I encourage you to do that. I'm going to give y'all 1 minute, put in the calculator. Yash on YouTube. The best way to reach me about anything chemistry and engineering related is to go to my TikTok. Here's my @ so that you can go to my TikTok and ask me engineering related questions. I talk about engineering sometimes. That's my @ I also love to talk about Chegg on there. So check that out for any engineering questions you might have. So now let's put this in the calculator. We're going to do 700 times 5,280 times 12 over 365 times 24 times 60 times 60. So I'm going to put that in the calculator. 700 times 5,280 times 12 divided by 365 divided by 24 divided by 60 divided by 60. You should have gotten 1.4 inches per second. So that's pretty cool. Maybe that's how far, I don't know. Maybe that's how far a turtle is traveling or something. I don't know if turtles travel that fast, but that's our value, 1.4 inches per second. Hopefully that makes sense. Again, if you're confused at any of the conversions I chose, any of the conversions I did, so I encourage you, type that in the chat. Now we want to find the equilibrium concentration of the following if I start with 4 molars of each reactant. So this is going to be a rate of reaction problem. If you're not familiar, don't worry, we're going to get to it. But I'm going to give y'all let's do 1 minute. Tell me anything you know about this problem. So 1 minute, anything that you know about how to solve this, let me know. For questions about engineering on Instagram, same @ is my account where I post about engineering as well. So that's also for Instagram. Again, 30 seconds, anything you know about this problem. It's a little bit more confusing, probably the most difficult one we've done today, but I wanted to save the most difficult for last. So anything you know about the equilibrium concentration of the following, let me know. About 10 more seconds, guys. Start typing in the chat anything we're thinking. All right, 3, 2, 1. So for this, we need an ICE table. ICE stands for initial change equilibrium. We want to find the equilibrium concentration, so that equilibrium row, super important. We start by writing our initials. Actually, first thing we do that I always forget, and it's counted me off a lot of points on tests because of it, is balancing that chemical equation. So I'm going to balance it. This one's super easy to balance, so I gave y'all a break for this one, but 1K, 1K, 1NO3, 1NO3. So this is already basically balanced for you all. Now I am going to plug in my concentrations. I start with 4 molarities of each. Molarity is moles over liters. So 4 M's, 4 M's, and then it doesn't say anything about how much product I start with, so I can assume 0 molars on this KNO3. Now I need the change. If there's coefficients, so let's say this was 2K, my change would be minus 2x. Since the coefficient is just 1, it's just a minus x. Reactants always have minus signs. Products are plus. So reactants minus signs, products plus. That's because you can kind of think of it logically. Reactants are going away to create product. So we're subtracting amount from our reactant to create product. So minus x plus x. Plus for the products because we're going from having no product to creating product. Hopefully that makes sense. If you have any questions on it, let me know. Our last column is our equilibrium column. And for that, we basically just drag everything down. So 4 minus x, 4 minus x, x. Hopefully that's making sense. Again, any questions you have, type them in the chat. That is our equilibrium values. Now to find the actual values, not just the ones with x, we need to find a K equation. K is always products over reactants. So let's do products over reactants. We would do the concentration of x over 4 minus x times 4 minus x. Now, where did I get these values in brackets, you might ask? Just right from here. Our K is the value of all of these in brackets. And then our problem tells us K equals 2. So we can now create an equation that 2 equals x over 4 minus x times 4 minus x. Correct equilibrium constant is K. So we have this now. What we want to do is solve for x. There's one thing I kind of want to point out before we go ahead and solve. Just like we had 2k over here and that made a change of minus 2x, when we do equilibrium constants, if we have a coefficient of 2, that minus 2x is going to be squared. If we have a coefficient of 3, that minus 3x is going to be cubed. That's just a rule of ICE tables of K equations. So it's an important thing to know. It's not really relevant for this problem, but I did want to point it out in case we had any questions revolving that, and if y'all had any homework help that you needed about it. If you do have any problems with that 2 coefficient, 3 coefficient that you want to go over, type those in the chat. I'd be more than happy to help. Now we're going to solve for x though. So we need to do some good old algebra. We have 2 equals x. Let's FOIL the bottom. So I'm going to do 4 times 4 is 16, minus x times 4 minus 4x, minus x times 4 minus 4x, and then negative x times negative x is positive x squared. Now let's combine like terms. 2 equals x over 16 minus 8x. Good job, Yash, getting ahead on that math. 16 minus 8x plus x squared. Now we want to get all of our values over to the left to do the quadratic formula. So I'm going to do 2 times 16 minus 8x plus x squared equals x. And let's just multiply that out. So 32 minus 16x plus 2x squared equals x. Then I'm going to subtract x. So 32, let me make sure I'm doing this right. Yes, okay. 32 minus 17x plus 2x squared equals 0. Hopefully that's making sense. Now we're going to use our quadratic formula. There's a great song that you should look at on YouTube if you want to learn the quadratic formula by memory, but it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. Learned it from the song. This is our b value, or this is our a value. Sorry, guys. B and c. So let's plug all that in. Negative 17 plus or minus the square root of 17 squared minus 4, 2, 32, all over 2 times 2. So let's plug that in. Let's simplify. 17 plus or minus the square root of 17 squared minus 256. 17 squared, let me plug that in the calculator. I think it's 349, but I want to verify. It's 289. Glad I verified. All over 4. Okay, that's some good knowledge. Yash from YouTube said it's also a Dianatura formula also. So if you've heard it that way, that's the same formula. So then we do 289 minus 256 and the square root of that, which would give us 17 plus or minus the square root, or 17 plus or minus 5.74. I went ahead and did the square root of that, all over 4. And now we have two possible answers. We can do 17 plus 5.74 over 4. And we can do 17 minus 5.74 over 4. I'm going to plug both of these in our calculator. 17 plus 5.74 divided by 4 is 3.24, or 3.25 if we're rounding. 17 minus 5.74 divided by 4 is 2.81, or 2.82 if you're rounding. So we have these two values. Now we want to go back up to our equilibrium values. So we have 4 minus x, and x. And we want to think which of these is going to get us a more realistic answer. In this case, you really can't go wrong with either. Neither is going to give you a negative answer when you plug it in for x. Normally, at this point in solving the problem, either one of the x's is going to cause an equilibrium concentration to be negative. We can never have negative concentration. Since this is 2 that would not give us negative concentrations, my chemistry teacher always taught us that we choose the one that would get our reactants closest to 0. So just like Yash from YouTube said, 3.25, 3.22, absolutely correct. We're going to choose this one. So 4 minus 3.25, 4 minus 3.25, and 3.25. So we are going to plug all of that into our calculator. We are going to get the concentrations for K is 0.75. Concentration for NO3 is 0.75. And the concentration for KNO3 is 3.25. We are about at time for our live stream tonight. Thank you so much for joining us. If this was your first time, it was so great to have you. I encourage you to join more live streams. We have a QR code in the top left of all the different live stream hours that Chegg offers. They're so kind, trying to help people do great with college and coursework and high school work. So I think we have algebra, organic chemistry, regular chemistry, calculus, anything you can think of. Chegg offers a live office hour. So I encourage you, check out that QR code. Join us again next week. Same time, come with questions that you either went over in class or things you just don't understand. I'd be more than happy to answer them. I'm going to be here. Same time, come meet us on Chegg on YouTube or Twitch. It's so great to see you. Bye, guys.